Alright, so you guys had a chance to explore student work. This is the part when I orchestrate these in my classroom where it gets challenging. Students move at different paces. If you don't have some sort of follow-up ready to go, you're going to have people sitting around with nothing to do, and other students working, and some students maybe shutting down. For this particular problem, I don't have a sequel geared up for the day of, so I gotta have some other like ratio proportion stuff in my back pocket, or I gotta team up students who I can see are thinking about it different ways and ask them to talk to each other about how they solved it, or I've gotta team up someone who solved it with someone who's shutting down and see if we can pull them out of that funk. So we're now managing a group where each member is moving moving at a different pace. So the other thing I didn't tell you is that my personal choice, which I've enjoyed so far, is when I do this task with my 7th graders, it's the first day of our proportional reasoning unit. Because they've all had some experience in 6th grade, so I want to get my finger on the pulse of like, where are we at with proportional reasoning. So let's just do like a compare-contrast. If you hadn't had a chance to see these 3 methods, here they are. And if you had a chance to have some discussion about them, what do you do if you see these 3 different representations from your students? Like these, and also to be clear, these are authentic students' responses. I have them tell me what they did, and I scribe exactly what I hear, and that's what you're looking at. Mark, you start.
I would tell the students to label.
Label stuff. So first thing, I divided 400 by 160, and I got 2.5. The student says that, I write it down, and go, cool, why'd you do that? What's 2.5 mean in this problem?
Rotations around the track.
On the small track that equal the larger track.
2.5 laps on the small track that equal the larger track. The way I think of this is the way I make sense of fractions and divisions, is that 2.5 small tracks fit in the big track. That's one of the division models we saw yesterday. That's how I make sense of that. So that's why we divide it. We figure out how many small tracks fit into the big track. So I'm going to figure out how many small times fit in, if then 2.5 times should fit, 2.5 little times should fit in the big time. Whoa. Okay. Instead of saying that, I would say, cool, then why do I get to divide 75 by 2.5? And poke at that until someone can tell me that we're saying there's that many increments of little times in the big time, or however it gets phrased. So label stuff, because what does it mean? How are the red and blue solutions similar or different?
They're using
the inverse.
They're totally the inverses of each other. I don't know why anyone would do that thing in blue.
it works.
It totally works.
Well, that's a ratio set up the most familiar way. Small number over big number equals small number over big number.
If it's a fraction, it's nice because it's small over big, small over big.
Excited.
So that's skipping the fraction bits because fractions are scary, but
Totally.
Actually, when I saw the view, how I make sense of the 0.4 was I saw it as like 1%. So I knew like 0.4 it's the 40%. So the small track is 40% of the big track.
What's 40%?
And then in the bottom, you see like also what is 40% of the 75 minutes.
perfect.
And that's how it's.
Awesome.
Yeah, and they're definitely like, I can think of students who think in percents like all the time. I'm not that kind of person, but I have a few students who are, and that would be a great defense for this line of thinking. Cool, and then
Oh no, and that was like the green one.
dude, the green, what's going on with the green? What's up with the green?
Where did you get?
They turn the time into minutes instead of seconds.
Yeah.
Nice.
Because you had to keep track of the 1500s as not 1500s for a quarter of a minute.
Yeah, so we have a minute, 1.25 minutes. Gonna have a lot of students play around with the time 1.15. That's something to expect. Before we got back to the whole room thing, I helped students who did that discover that by asking them to compare their final answers. So at no point, so I haven't said anything yet about a right or wrong answer. I've asked them to compare answers with each other. The students who use 1.15 are gonna get like 46 seconds, I think. So that's Some would be perfect. Yeah, so what do you think would be more common in a room full of middle school students, the 75 seconds or the 1.25 minutes?
75 seconds.
Raise your hand if you think you're gonna see a whole bunch of 75 seconds. We've already put 1.15 over there. Raise your hand if you think you're gonna see a whole bunch of 1.25s. I can tell you probably like 1 out of 100 students did 1.25.
Yeah.
Why do you think that is?
Well, like, no, well, I was talking about this also earlier, the kids don't have a good sense of how the analog clock works. So like a lot of kids think a quarter of an hour is 25 minutes.
Yeah.
And I used 1.25 when I worked this out because Apple said that, and I was like, yeah, a quarter is like 25 minutes. I was like, no. So that's the only reason I use 1.25, but kids don't use that.
So kids struggle with the base 60 thing. It's a quarter of 60, not a quarter of 100. Why? Any other reasons why 75 might be more prominent? What would make me want 75?
A decimal, a whole number versus a whole number.
Whole number versus decimal for sure.
Yeah.
For sure. And we'll see later that like 75 is actually not that friendly of a amount of time to work with, whereas 1.25 is really not that bad of an increment of time to work with. Especially if we think about like tape diagrams and like visualizing 1.25s. Because if you divide 400 by 75, you get a mess. When you guys saw that, you get 5.333. Yeah. Okay. Cool. Yeah.
You know, I'm curious. I'm very amazed how like the kids know when to buy when times and all these, and these all these like confusing numbers.
Mm-hmm.
So I'm curious, before they come to this point, did they have like some kind of portion set up, or
No.
this is their raw work?
This is raw work. This is totally authentic. This is straight from my students from last year.
So there's no proportions.
Well, 6th grade they have.
So some 6th grade teachers, the 7th graders I'm about to get have not been taught by their 6th grade teachers how to set up an algebraic proportional equation. The 7th graders I had last year were shown that. And so you'll see, like, we'll just go to the next page. That's a great, like, authentic transition to this next page. So in green, I have a student who was taught that and used it. They set up a proportion, an algebraic proportional equation, and they solved the equation.
I like the red.
You like the red?
Just how I would
Isn't
never
that interesting?
how they
Define-
simplified it.
So and I put these on the
Anyone.
same page on purpose. Right? Like, why would I want you to look at these two solutions side by side?
What's the ratio?
So different ratio notations.
Right.
They're both proportions. The second student doesn't go straight to this classic thing that a lot of students see. Like, I don't like that personally, the green thing. I don't like teaching it to middle school students because they memorize it as a procedure and forget why it works. They know that there's going to be 3 things they know and 1 thing they don't, and they put them in those spots. Like, that's what they know, right? The first student was like, I'm going to look at the ratio of small to big, distance, I'm going to simplify it, and I'm going to think that ratio needs to be the same as the time ratio, and I'm going to figure out the missing part of the time ratio.
This
But
line
you
to
can
me is
manipulate that the green one anyway, as long as you're keeping the relationships the same. So the green is not necessarily plug and chug, because you can go 1600 to 400 is X to 75. I mean, you can manipulate, you just have to know how the numbers are connected,
Yeah,
which the kids might not know.
that's true.
I like the solution in red because that's a constraint from the student thinking. The green one, setting up the proportional equation, I had students in high school level, they still, make a mistake when they try to solve the proportional equation. So I think the red one is good.
Right, because it's like if you put the numbers in the wrong spot, then
Yes.
the portion doesn't work.
Yeah, in that red solution, I see the tape diagram thinking happening. I have 2 parts and 5 parts. My 5 parts on the time side of things are going to represent 75 minutes. So or 75 seconds. So this whole thing is 75 seconds. That's like 5 groups of what is going to make my 75 seconds. So that's where that 75 divided by 5 yielding 15 comes from. So it's like, that's cool. That means on top, I've got 2 groups of 15. Which is where which is how I get to my 30 seconds.
Oh, awesome.
So there's your tape diagram in this problem, which I think is cool. Can we go to the last set of student work? Questions, comments, insights about these students? Yeah.
Where are you, like, rewriting this on like an iPad or something?
I write this on an electronic, on a smartboard.
Okay.
Yeah,
So
so
you
I'm
can record.
scribing on, I'm scribing on a smartboard. I'm trying to write exactly what students say. If they say things I don't like, I poke and I ask questions before I write it down.
You don't want them to come up and write?
No, it's like, I personally, when I do this, I don't usually have students come write. It's super clunky. You either need to devote, who has smartboards? Who lets their students come up and write on their smartboard? You guys cool? Okay, cool. I like never devote the time to letting kids get comfortable writing on the smartboard. It's clunky. It doesn't know the difference between your hand and the pen, so you rest your hand on the thing, and then like spatial, it just gets everywhere. And I do want to help students get better at their spatial reasoning, but I also have like 55 minutes to like get this going. So I have them talk, I write, and when they tell me like if we're, say we're multiplying something by 10, and they say, so I added a 0 on it, then I add a 0 on it. And they get all bummed at me because I just went +0. I do stuff like that when I'm scribing, which you'll experience in a
Make
moment.
them literal.
Yeah, I do. I mean, so it helps them with the precision in their descriptions of what they did. Did I see another hand about this before? Yes,
So
sir.
sometimes what I like doing, maybe this isn't like Dan Meyer's method, is as I'm looking at what other students are doing, if I see unique solutions, I'll have my students show their solution underneath the document card with their own work.
Yeah.
And they have to actually narrate their work, and then we're always like, okay, ask questions, use sentence starters, what's going on? Because then you're also getting that verbal explanation of, you have this kind of gobbledygook or making assumptions if you're just looking at it.
Cool.
But then their work has an audience.
Yeah. Yeah.
And
Thanks.
that's what's nice, and then kids can go like, oh, that's interesting, and sometimes it makes it different when they see, it makes a different impression on students when they see student work in that student's handwriting with the student explanation.
Totally. Thank you. I'm glad you said that because I didn't think at this moment. Yeah, I don't scribe all the time. Scribing is a strategy I use for showing student work. I do a lot of doc cameraing. So through this process where students are moving at different paces, before I'll ask two students to compare their methods, I might put it under my doc cam and take a screenshot of it on my computer and have it to project up for later, or I might have them put their paper notebook under the camera in real time, stuff like that. And I might actually, if I do their notebook, instead of having them defend their notebook, I might just do like a, what do you like about this, what would you do differently, kind of a discussion, and not let them defend it, and keep it anonymous that way. So if I'm like pulling student work while the whole class is working, I can keep that work anonymous and it's safe, especially if I want to grab a common mistake to show off. And it's safe because no one but that kid knows it was theirs. Strategies.
So if I ever do something like this in group work, because sometimes you have someone who's really good at scribing or two people because they're doing grouping, I'll pick the work that is the most legible, but have the student who is like the more verbal learner, maybe I'll be the one to explain it.
Nice.
Because then the person who really knows the math has to explain it to the point of understanding to the other student, and then that student is kind of like the hero of their group in explaining that process, and then that's another time to learn for them.
Yeah. I also want to push students to be able to read math. Right? So I'll show them someone else's solution and just say give them time to read it. And then ask them what happened from this step to that step, what happened, and so on. Thanks. Let's look at that. Let's look at this last page. I don't want to stall it too long. So I want to plan a really. So remember Crystal's calculator? Okay. So I want to pose the concept that one of these students used the calculator and one of them didn't. And
Shocking.
and this shocking. And this is what. Clearly the student who didn't use a calculator has a really strong sense of how to manipulate symbols. And that's awesome, right? But for whatever reason, I sort of intrinsically value the student who didn't use the thinking demonstrated by the student who didn't use a calculator more. I have a hard time with the calculator discussion. I'm a maybe. If I was in the discussion yesterday morning, in my first years of teaching, I was super anti-calculator, no calculators anytime. After FAME, I was like, calculators all the time. And now I'm like, I think I'm gonna have calculator days and no calculator days, and this is why, right? It's like the student who is afraid to work with 1 1/4, because it's not a whole number. If they had gotten to 1 1/4, it might have been easier to work with than 5.3 repeating, right? So same idea, the kid who couldn't just go punch it in, because I restrict them just a little bit, they might come up with a way of thinking about the problem that's just super clean, simple, beautiful. Like that's what I love, that's what I like about math.
We had an issue with the 5.31 because the person who did this swapped sides and I didn't understand where the 5.3 repeating came from. And it then became, wait a minute, this doesn't make sense, I don't understand it. And then we looked at it and we had to figure out where the 5.3 came from because it wasn't kept.
Right.
And then she puts it back on the X back on the other side in the end, so he or she, I don't know.
Yeah.
But it was not linearly, step by step, aesthetic for me because I like things in order. And it confused me.
It seems like she wants X to be on the left, but she could have just left it alone and it would have been on the left by the time she got to the end, because she had to multiply both sides by X.
But I don't think she realized that, so they just flipped it and
Totally.
they just kept going.
Yeah. Nonetheless, like, this student knows what they want and how to get there. They didn't see a few steps ahead on that regard, but yes.
One of the things that I put in my notes under questions is like, what conversions do I need to think about? You know, at the very beginning, and I was thinking about why did I say that? Partly because I feel like that's one of those times when you have to decide, what do I want them to get out of the lesson? If I've got 15 minutes or 55 minutes, do I want them to get stuck on conversions of 1.15 to 1.25, or do I want them to get through this process? And those are things that you make a judgment, and sometimes it works, and sometimes it's like, we're going to try again. So I think that all the questions that the kids say are probably pretty valuable. To spend that time in the beginning of what do you think you need to know, because that might come up and save time if you judge that you want to speed through that and give a quick
That time conversion?
Yeah.
That time conversion could be a seed you plant in the what info do we need, so that it doesn't trip them up, because the thing we're measuring is proportional reasoning. Though there is there's an element of proportional reasoning in there, but and the unique thing about this is obviously I want them to learn something all the time, but this is I want to learn. My goal is to learn about them in this lesson. I'm using this as a pre-assessment.
Right.
And they're certainly going to learn in the pre-assessment, and that's fine, because they should learn as much as they can as often as they can. Questions about this?
I didn't even think about the greatest.
Rowan, that's a good one.
Right.
I know there were some different methods in the room. In the interest of reading your eyes and paying attention to the time, I'm just going to go ahead and move. So one more thing that I use this for with my students. So a way that I follow it up is I wait about a week or so after we've learned about ratios and unit rates and proportions, and I come back to the problem and I show them 4 proportions that might have been used to solve this problem, and I tell them, what do I tell them? I probably just tell them that one works and one doesn't, or one works, nope, one doesn't work and the rest work. Why?
Agreed.
Green does or doesn't? Green doesn't work. Let's all hone in on that.
Yeah.
Green doesn't work. What's wrong with green? Right? This is to address that misconception of there's 4 slots, one gets an X, 3 of them get numbers, and then I go. So what's wrong with green?
The 75 should go with the 400, not the other.
So we can see the 75 should go with the 400 because the 75 is the outdoor time and the 400 is the outdoor distance, and those should be together. Do you want to challenge that?
You wouldn't give them the time tags today?
Say that again.
You wouldn't have given them the time
I
tags?
would. I actually give them I wanted to make them big enough for you guys to see on my smartboard. I get a little bit more bang for the buck, but I put these 4 proportions above the picture above this picture.
Okay,
Yeah.
because I wouldn't forget.
Probably could have snuck that all on one screen for you guys. But yeah, so I give them, because it's like a week or two later, yeah. Did anyone want to challenge the fact that like we should swap X to 75? Did anyone have a different suggestion?
Not really, the way I would word it is that I see it as like a square, and that the two vertical columns are intrinsically linked and the two horizontals are. And so the X has to be between 75 and 160, wherever it is. That's where the X has to be.
X has to be between
160.
If you're turning the corner,
Yeah, thank you.
X is between 75 and 160.
Or it has to be diagonal
Oh.
from the 400,
So
no
you
matter
say-
what.
Right now it's between 400 and 75 is what you're saying?
Right.
That's correct.
And it needs to be between,
Got it.
75 and 160.
In every other,
Or
every
diagonal
other
from
setup.
400.
or diagonal from 400.
Which is probably a better.
So if you look at the other three representations, the X is between 75 and 160, or diagonal from 400, yeah. And you also said something about these vertical and horizontal alignment. Do you guys get what she means by that? Someone build on, someone say more about that?
The way I look at it is in the red, we have on the top, we have our distance. Then on the bottom, they're both time. And the time for the 400, we know, the time for the 160, we don't. On the blue, we have the time on the top, the distance on the bottom, they're still linked. On the last one, we are comparing distance to distance and time to time. We are comparing either across or up and down the same item. And in the green, it's because the 75 is not combined with the 400 that it's a mistake.
Check this out. I took away the numbers. I put in qualitative descriptions of the value. So I have outdoor distance over outdoor time versus indoor distance over indoor time. So qualitatively, we have distances and times. We have outdoors and indoors. So it's really, there's like four things that we're juggling, and common features need to be aligned vertically and horizontally. So if you look at green, you can see that there are no common features. Well, that's not true, but not that there are no common features, but we don't have.
They're not aligned vertically or horizontally, they're aligned diagonally.
Right. Yeah.
So you have two main quantities that you're comparing, time and distance, right? I'm just thinking if you set up a ratio table, you're like, the time, the distance can't be in the same spot, because you've already labeled, like, time is either going this way or it's going down, depending on how you label it. So if you set up a ratio table, and then if you wanted to show them how to set the proportion, then you're like, okay, it still has to reflect what your ratio table looks like.
Right. So my point in all of this follow-up stuff is that I think that if we set up all this strong contextual background, the stuff we did this morning with all those models, talking about the meaning behind these kinds of calculations, I think that that's going to help us avoid the green kind of misconception, which I heard a lot of people say they see students making.
I'm just gonna add this, because we did use 75 seconds for the short track. So it was still an indoor time, so I think that was the main misconception.
Ah, good point.
Probably like, I'm thinking for my students, I have to break it down, so it'd be like, that's the, call it the fast time as opposed to the indoor.
Sure.
Because they're going super slow in the green line.
Right, what Guy is pointing
Oh,
out,
yeah.
that I totally didn't realize
It's the
is, when Dan started the problem, he was trying to use 75 as an indoor time, but it was problematic for him. So there could be some contextual misconceptions there.